Let's graph a simple rational function, 2 over x squared plus 1. Now when we graph a rational function, we have several steps to go through. And in no particular order, these are, first we might find the y-intercept. Just plug in 0 for x and find f of 0. We need to find the x-intercepts, which are the roots of the function. We can find the vertical asymptotes by finding the zeros of the denominator. We can find the horizontal asymptotes by asking what's the limit of the function as x goes to infinity. And finally, we can look for holes when we have the same binomial in the denominator and the numerator. Alright, so let's apply these steps to this function. F of 0 is just 2 over 0 plus 1, which is 2 over 1, so that's 2. So I'll put this on this graph here. The function passes through the point 0, 2, and so I know 1 point on this function. Let's find the zeros of the function. Now remember, these are the zeros of the denominator, or excuse me, the numerator, so there aren't any, because 2 is never equal to 0. So we know an important thing about this function: it never crosses the x-axis. Now the vertical asymptotes are the zeros, if any, of the denominator. So we set x squared plus 1 equal to 0, we get x squared is equal to negative 1. So x is an imaginary number, which means there are no real zeros of the denominator, so this function also has no vertical asymptote. Now for the horizontal asymptote, we're asking what is the limit of this function 2 over x squared plus 1 as x goes to plus or minus infinity. And as that happens, this function goes to 0, because as the denominator gets very large, the function itself gets very small. So now we're ready to graph this function. We know that it goes through y equals 2, that's the y-intercept. We know that it never crosses the x-axis and that it has a horizontal asymptote of y equals 0. So this is really the only graph that we could draw for this function. Notice part of the symmetry of this function too. This function can never be negative because whatever x is, it's always squared. So the values of this function are always positive. Another way to say that is that the range of this function is all positive numbers. And finally, here's a graph of this function that I calculated using Mathematica, and you can see that we are right on the money. Our sketch looks just like the calculated graph.